All right, what's up, guys? How you guys doing? I hope you guys are doing well. So we're on chapter 2 right now. Chapter 1, you should be solid, right? Practice as much as possible. We're gonna dive into chapter 2 right here. Okay. All right. This is what I expect you to know. But if you don't remember, this is in Gen Chem 1. Don't worry about it. We'll review just a little. Okay. All right. I'm sure you have seen electron configuration before, where you learn about p orbitals, s orbital, d orbital, what they look like, how you fill up electron. 1s2, 2s2, 2p2, something like that. Okay. And we have talked about Lewis structures, right? And you did that. Practice that, learn about this first time in Gen Chem 1, right? So where to put central atom, non-central atom, how to put electrons and bonds. This one is from Gen Chem 1, so valence shell electron pair repulsion theory tell you how the geometry of atoms, not atom, of molecules. So we have a linear, we have trigonal planar, tetrahedral, and bent, and so on. Okay, all right. Question that we still have to answer. Maybe you have learned this in Gen Chem 1, but I don't expect you to remember it. Okay? All right, it's just small part in Gen Chem 1 there. All right. How do atoms form a covalent bond exactly? All right. What we learned is in Lewis structure that two atoms form bond. They just share electrons, right? One electron from one atom, another electron from another atom that share, and we call covalent bond. So two electrons in a bond, basically, right? If this is true for all atoms, how come do the bond between hydrogen atoms and fluorine atoms are different? Look at the bonding energy. The hydrogen is much stronger than fluorine bond, right? And shorter, and fluorine is longer. Why is it different though? If it's just sharing two electrons, something is different there, all right? So we have a theory to explain what's really going on inside right here, all right? So we call it valence bond theory. You learned this in Gen Chem 1, but let's say if you remember that, all right? All right, so valence bond theory is a long theory, but I'll summarize it into just 2 points right here. Important point. 1, covalent bond is formed when two half-fill orbitals on different atoms overlap. Here's what I mean. Let's say if these two hydrogen atoms want to form bond, each one of them have to put out one half-fill orbital, all right? And they can share. So they can share electrons like that, all right? And this makes sense. If an atom doesn't have a half-fill orbital, they cannot form bond. For example, helium, which is inert gas, you guys know that. 2 electrons in helium is full, right? So helium can't form bond, they repel. Okay? So my point is, if an atom want to form a bond, it needs to have at least one half-fill orbital. Hydrogen want to form bond, one half-fill orbital. Hydrogen want to form bond, one half-fill orbital. So 2 total here. All right. All right. Number 2, the greater the overlap, the stronger and more stable the bond. Right. So there are 2 types of overlapping in the valence bond. According to valence bond theory, we have head-to-head to form a sigma bond, and we have side-to-side. We call pi bond. All right, and sigma bond have a better overlap than side-to-side overlapping. So sigma bond is stronger than pi bond. Head-to-head is relatively stronger bond. Okay, all right. How do we explain the different property of bond between hydrogens and fluorine? Okay, well, the hydrogen atom form bond by using one s orbital, but in fluorine they use 2p orbital, and p orbital is much longer than s orbital. S orbital is just a circle, not circle, like the sphere. Okay, and that's why this hydrogen nucleus is getting closer, more closely than fluorine nucleus and the electron. So the bond length is shorter, and when they get closer, so it's stronger as well. Okay, all right. Now there's some limit. Nothing is perfect. Some valence bond theory have some limitation. And here it is, okay? So methane, we know that, so the structure looks like this, a tetrahedral, carbon form 4 bonds, right? 4 bonds, tetrahedral. Now, according to valence bond theory, if this carbon want to form 4 bonds, how many half-fill orbitals this carbon need to have? If you still remember, hydrogen atom, right? So hydrogen atom want to form bond, it have to put out one half-fill, another hydrogen, one half-fill, right? And then combine. This carbon want to form 4 bonds. It needs to have 4 half-fills for each hydrogen right there. Okay, so if carbon want to form 4 bonds, according to valence bond theory, this guy got to have 4 half-field orbital, and each hydrogen will come overlap. All right. Now, here's the problem though. If you look at the electron configuration of carbon, 1s2, 2s2, 2p2, how many half-field orbitals are there? Only 2. See that? Which means that this carbon cannot form 4 bonds. That's the limitation of valence bond theory. Valence bond theory fails to explain how atoms form bond in any other molecules. Right? Hydrogen works, fluorine works, but most molecules, valence bond theory cannot explain it. But let's say somehow these carbon have 4 half-field orbital. I'll take a look at the valence shell of carbon. So we have 2s orbital, 2p, this is px orbital, py, pz. Okay, somehow out of thin air, this carbon have 4 half-field orbital. Look at that. So each orbital have 1 electrons. Right, and then for hydrogen come to overlap. What geometry is that? That doesn't make any sense, right? So valence bond theory failed to explain how atoms form bonds in the molecules and how to explain the geometry. Okay, so we need to have a different theory to help valence bond theory explain how these work. Let's take a look at the next video. Okay.